Great job. We see both of you now. Hey, where's Don?
Don would be back here, but we can't get him out of the commander's seat.
Somebody's got to keep it warm.
That's just not true.
Hi there.
And this television still from Discovery as it flies across and over Central Africa, 140 nautical miles high, with thunderstorms, very severe thunderstorms below across that continent.
Discovery Houston for Greg.
Go ahead, KT.
Yeah, the flight director says it's okay if you want to take a circuitous route back to the pre-cradle position to make up for what he took away from you yesterday.
Okay, I'll accept that. Thank you. He just broke his heart, KT.
Yeah, it sounds like it.
We're now receiving live television from the flight deck of Discovery. This showing mission specialist Greg Harbaugh as he works the mechanical arm, taking it back to a cradled position, powering it down, and finally it will be stowed and latched back into place. The next time the arm...
Discovery Houston, we're on the flight deck with you.
The next time that Discovery's mechanical arm will be uncradled is for that deploy, the grapple of the shuttle pallet satellite and the infrared background signature survey, and unberthing and then release of that. This is Mission Control Houston as we're still watching live television from Discovery. This is the cryogenic infrared radiance instrument for shuttle that has been the center of activity over the past 2 days. As it moves into position and the top opens in order to begin its final observation, which is basically a calibration and fine-tuning of the instrument just to double-check to have a baseline measurement after all of the observations that it has made during the past 2 days prior to the crews turning that instrument off and stowing it away.
Discovery Houston, we see good SPOS attitudes and rates. You have a go to unberth when you're ready.
Okay, that's what I've been waiting for. Thanks, Brian. I'll put it in work.
Crew aboard Discovery now stepping into the part of the timeline to begin the unberth procedures for the shuttle pallet satellite. That involves releasing some of the payload retention latch assemblies that are holding the SPAs in the payload bay of Discovery. Mechanical Systems Officer reports that the payload retention latch assemblies have been released. SPAS is now being held in the payload bay of Discovery by the remote manipulator arm as the orbiter now passes right directly over Sydney, Australia on orbit 46. PDRS officer reports that SPA is now being unberthed from the payload bay of Discovery. Payload Deployment and Retrieval Systems Officer reports that the SPAS is in the low hover position on the end of the Remote Manipulator System Arm or Robot Arm aboard Discovery. Flight Director Bob Castle now polling the room to get a go from all flight controllers for release of the shuttle pallet satellite from the end of the Remote Manipulator Arm.
Houston Discovery for payloads.
Go ahead, Discovery.
Okay, Brian, the antenna checkout went real well. Looked like SPAS would lock up on any antenna without my having to turn modulation off and sweep at all. Just for the sake of demonstrating it would work all right, I went ahead and turned modulation off on each antenna, and that's when we got the bit sync annunciation. But it looked like it locked on without any difficulty. We did see the RADI data on 2 of the antennas, and that's what we had sort of anticipated.
Okay, Greg, yeah, we agree, and we saw all of the same indications. Everything looked real good to us. Discovery Houston, we'd like you to switch back to the wide L-Cube TV now.
Roger.
Looking at into outer space from one of the wide field cameras mounted on the infrared background signature survey. As this view of the Southern Cross through that wide field camera.
Discovery Houston.
Go ahead, Brian.
Hey, Mike, we're getting a great downlink. We see the only thing we have left to do is the DAP config, collapsing the deadbands, and once that's done, you are go for release.
Okay, once we get to the DAP, we're go for release.
All flight controllers now have given the go for the release of the shuttle pallet satellite from the end effector of the Remote Manipulator Arm aboard Discovery. And release is confirmed of the IBSS SPAS. The orbiter is in free drift. Shuttle pallet satellite's now a free flyer. Next step is to maneuver Discovery away from the satellite. Now executing a maneuver of the shuttle pallet satellite. This is a maneuver to verify the attitude control system of the satellite.
Houston Discovery, the ACS checkout looked real good.
Looked great to us also. And Discovery, you probably saw it. It looked like it overshot just a little bit, corrected back, and is now fine. And you are go for SEP.
Roger, go for SEP.
Separation berm confirmed on time. Discovery now performing an acceleration burn or posigrade burn. That is a 2 foot per second burn as Discovery moves up and away from the shuttle pallet satellite and the infrared background signature survey. Flight Dynamics Officer reports the actual burn was 2.21 feet per second away from the satellite. Discovery now on orbit 47, traveling across the North Atlantic Ocean, approaching Ireland.
Discovery Houston, we saw a great SEP burn. Mike, you missed the target by a whole 0.01 feet per second. Good job there. And we need to have the operating tank refilled, please.
Okay, we're refilling the operating tank. And tell us again what Delta V you got.
2.21.
Roger.
Okay, yeah, Greg, we're getting a great picture. Looks like a family photo.
Okay, Brian, that's enough FaceTime. We got to go back to radar now.
Okay, I guess you got to go back to work. And Discovery Houston, for the payloads, if you put us back in oiler mode, we'll ship you up the numbers for the next maneuver.
This is Mission Control Houston. The flight controllers are still looking at different attitudes to maneuver the SPAS-2 after its sun sensor recognized a bright object and changed the attitude of the shuttle pallet satellite. And that is a procedure that is built into the satellite and the payload to protect those instruments if in fact a bright object such as the sun comes into view. It changes the attitude. So the sun sensor recognized a bright object and did just as it's designed to do, and that is to change the attitude of the payload to protect all the instruments.
Discovery Houston, Rick, got the attitude where we believe we are right now, so you can load it in the PGSC and see what you think.
Say again?
Yeah, we have the attitude for you to load in your PGSC.
Oh, okay, let me get a pencil. Okay, tell us what you got.
Okay, we believe it's at roll 13.11, pitch minus 28.50, yaw minus 105.31.
Okay, let's see what we got.
Discovery Discovery Houston, cancel the burn maneuver. Discovery Houston, radio check.
Okay, KT, we copy. Cancel the burn maneuver.
Okay, the reason is we need to check the attitude to make sure that we won't cause spas to go into a dither as we maneuver to the burn attitude, and we're not quite ready yet.
Okay, we'll wait.
This is what the starry sky looks like in the southern hemisphere, just south of Africa. This view of the stars is taken courtesy of the low light level cameras on the Pallet satellite. This is Mission Control Houston. The theory of the couple of flashes that occurred on the bright spot that is moving towards the center of the screen is that those flashes coincided with station or vernier burns, or burns of the vernier engines.
KT, that's definitely the orbiter. What you're seeing, the flashing, is me turning the flashlight on and off.
Are you serious?
Yeah, absolutely.
We were just going to ask you to ident.
That's the closest we can do to ident. Unfortunately, I think that means we're not quite, hey, you know what? We could go LVLH and then center this thing up. The attitude must not be too wrong.
Stand by, let us think about that, Rick.
Discovery Houston, you have a go to take data.
Okay, thanks.
This is Mission Control Houston. We're now about a little over a minute and a half away from the deploy time for the Crow-C sub-satellite. Everything has been proceeding along smoothly in the control center. And on board Discovery, that last communications with the spacecraft dealt with the observations that are ongoing with the shuttle Pallet satellite. Those are observations of the Earth as it's being remotely operated by mission specialist Greg Harbaugh from the aft flight deck of Discovery. Harbaugh will also be the crew member responsible for deploy of the Crow-C sub-satellite. Discovery is currently over the mid-Pacific Ocean on orbit number 58.
Discovery Houston, the state vectors look good. You have a go for deploy.
Okay, Marcia, and Crow C is away.
All right.
This is Mission Control Houston. The Chemical Release Observation C subsatellite is now away and deployed from Discovery. Currently, flight controllers are standing by for the crew to shift the KU band antenna, the dish-shaped antenna on board Discovery, from its current radar lock on the Shuttle Pallet satellite to a radar lock on the Crow C subsatellite.
Discovery Houston, we need you to manual slew on the radar to break the lock on the SPAs, then slew the radar to the elevation as seen in the COS.
Okay, we'll do that.
That call to the crew dealt with working with the KU band antenna, the dish-shaped antenna, to switch the radar from the Shuttle Pallet satellite to the Crow C subsatellite. The flight control position in the control room that is responsible for overseeing the rendezvous radar and watching the distances between Discovery and the Crow C subsatellite as they separate is the rendezvous officer. On this shift, rendezvous officer is Chris Meyer. Currently watching now and waiting as it's reported that the KU band antenna has now been switched off of lock from the Shuttle Pallet satellite and will enter a search mode to look for the Crow C subsatellite. The Crow C subsatellite was ejected from Discovery by a spring-loaded mechanism that adds velocity to it, enough to put it in a slightly higher orbit than Discovery's.
We're locked up on it now.
Okay, copy.
And radar is now locked on the Crow C subsatellite. The current distance between Discovery and the Crow C is 1,090 feet. Two are separating at a rate of about 4 feet per second.
Houston Discovery for the payloads folks. As the canister came out, it tumbled more or less end over end, and we estimate about 15 degrees per second tumble rate.
Okay, copy that.
And that report from the crew that the Crow sea canister was tumbling at about a rate of 15 degrees a second as it was deployed is no problem. It's no trouble at all if the Crow sea is tumbling.
Discovery Houston, you have a go for step 5 on page 10-5.
Okay, Marshall, we were waiting for 10 minutes, but we'll do that now.
We're happy with what we see.
Flight controllers here in Mission Control are now tracking 3 objects, 3 independent objects in orbit. That's the maximum amount of objects that have been tracked in orbit during the shuttle program from Mission Control. And Discovery's radar has now been switched back to the shuttle Pallet satellite. The last indication from the radar showing the Crow Sea was that it was about 1,600 feet distant. Those persons responsible for tracking the satellite, the Crow Sea subsatellite, as well as the shuttle Pallet satellite and Discovery, are the flight dynamics officer here in this view from Mission Control on the left-hand side of the screen, the trajectory officer, as well as the rendezvous officer.
ahead.
Marcia, the ratios look good. You want us to go ahead and do filter to prop here?
Stand by. That's firm. You have a go.
Roger.
This is Mission Control Houston. The Crow C subsatellite has now been free flying for about almost 20 minutes. It's currently still moving away from Discovery. We have a animation that shows the chemical release observation C subsatellite's destiny over the next few hours. That depicts the activities that will take place. This is an animation of the deployment which just occurred. Although it was not intended to deploy in a tumbling fashion, as was reported by the crew at 15 degrees per second, that's not expected to pose a problem for the operations with the satellite. The Crow C subsatellite will deploy a radar reflector from the front and an antenna from behind for communications with the Vandenberg Air Force Base. Over about 3 orbits, it will drop behind Discovery due to the 4 feet per second with which it was expelled from the payload bay, and a higher altitude orbit it will go into. At 1 a.m., a little after 1 a.m. this morning, Discovery will perform a burn that will shorten its orbit and allow it to cut a corner and move within 1 mile of the shuttle pallet satellite. At that point, Discovery will repeat its engine firings for observation by the shuttle pallet satellite. Repeat performance of what was done today. Crow C will be observed first with a checkout pass over Vandenberg Air Force Base, and that's scheduled to occur tomorrow morning, and then release its gas. Its contents are nitrogen tetroxide, which is a common rocket propellant, and the rocket propellant on board Discovery. That release will occur over Vandenberg Air Force Base and be observed by the shuttle pallet satellite as well as ground controllers at the Vandenberg Air Force Base and airborne instruments flying underneath the chemical release observation satellite. That gas release by the Crow C subsatellite is scheduled for...
Go ahead.
Okay, Marshall, we'll be ready to copy the NCSK-3 maneuver pad when it's ready.
Been waiting on it. I'll call you as soon as I get it.
Thank you.
And again, that Crow C subsatellite gas release is expected to occur about 9:12 a.m. tomorrow morning.
Discovery Houston, target's coming to you, still waiting on the pad.
Roger.
And even as I speak, I have the pad for NCSK3 when you're ready to copy.
Yeah, Marcia, we see the targets on board.
They're on board and they look good.
Roger that.
Greg, I'll read you the notes from the maneuver pad if you're ready.
Go ahead, Marcia.
Okay, ohms gimbal check, post burn, left primary and right primary. RCS interconnect, right ohms to RCS. Down mode options, none. Ohms helium reg test, NA. IMU deselect, NA. Other notes, We'd like you to change DAP-A norm deadband from 5 degrees to 2 degrees for the burn. Post-burn, you can configure it back to 5 degrees and use DAP-B norm tail only to maneuver to and from the burn attitude.
Okay, we copy home gimbal check, post-burn left primary, post-burn right primary, RCS interconnect right ohms to RCS, downward options none, ohms helium rec test NA, IME deselect NA. We'll set A norm deadband from 5 degrees to 2 degrees, and post-burn back to 5 degrees, and we'll use B norm to and from the attitude.
Good readback.
This is Mission Control Houston. That last communication to Discovery was about an upcoming station keeping engine firing. Those are necessary to keep Discovery at its point, a little over 6 miles behind the shuttle Pallet satellite. We're currently about a minute away from ignition of that station keeping firing.
Houston Discovery for CIC.
Stand by on CIC.
This is a very small firing that scheduled to last about 3 seconds and only changed Discovery's velocity by about less than a foot per second.
Houston Discovery for CIC.
Stand by on CIC. Discovery, we see a good burn. We'd like to inhibit data.
Roger, we're inhibiting data.
And that was confirming to the crew that their station keeping engine firing using the steering jets aboard Discovery, the reaction control system jets, went perfectly. Very small engine firing that's required every so often just to maintain Discovery's position around the 6 mile point behind the shuttle Pallet satellite. Discovery drifts and does not stay permanently in that point due to the fact that the reaction control system is always on board the spacecraft to keep its attitude steady or its orientation, and those small engine firings that are automatic and fire whenever they sense that the orbiter is moving out of a certain orientation. Those firings slowly build up to the point that Discovery tends to drift slightly, and these burns correct that for that drift and put Discovery back at that station keeping spot.
Discovery Houston. Guy, go ahead for CIC.
Roger, CIC, Discovery.
Go ahead, Discovery.
Okay, another NC06, read down, Roscoe. Hop is off, Echo 530 reads 36.00, and Echo 531 reads 33.28, and I'm ready to read down TCE 70 log.
Roger, we're ready to copy.
Okay, starting at the top, 6.4, 6.4, 8.2, 11.9, 24.1, 24.1, 24.3, 25.8, 27.0, 27.0, 26.3, 30.0, 55.9, 55.9, 58.1, 98.6, 96.4, 103.0, 0.61, 45.3, and 2.8 times 10 to the fifth.
Okay, I'd like to verify lines 18 and 19.
Okay, line 18 is Charlie 765, and that's 98.6, and line 19 is 96.0.
Roger, and next page.
Okay, second page. Off, on, manual, 0, 1, 1, 2, 3, 33.5, off, 0, primary, 4.95, 12.6, clear, on, 51.2, and 29.5.
Roger, copy, Guy, and we're ready for TE55 when you're ready.
Okay, and leave the CMC power on, or do you want me to power it off?
Leave the CMC power on.
Okay, I'll skip 14 in this message then.
Affirmative, and that'll be until further notice.
Okay. And I'm ready to read down the T55.1 log to you, Roscoe.
Go ahead, Guy, I'm ready to copy.
Okay, here we go. Page 1, minus 2.1 times 10 to the minus 6, 59.42, 57.35, 4.88, 103.4, 3.68, 6.09, 0, 0, 0, 0, 0, 5.32, 44.56, 96, 1.60, 3.0, 1.24, 1.14, 1.0, and 255.
Roger, next page.
Okay, page 2. 6, 3, 2, 384, 2962, 2968, 19.9, 84.47, 102.66, 34.92, 39.22, 83.86, 85.08, 65534, 65534, 7, 510, 103.4, and 113.8.
Roger, that's good. Read down, and we're ready for TA-10.
Okay, TA-10 starting at Alpha 512, 4.88, 103.9, 0, and 2.004.
Roger, copy.
For Alpha 568, 1105.91, 1411.80, 3.68, 6.09, 0, 0, 0, 229, 104.3, and 68.9.
Roger, I'd like to verify line 16.
16 is Alpha 572, reads 3.82.
Roger, next page.
Okay, Roscoe, starting on page 2, Alpha 569, 53.65, 37.88, 0, 0, 0, 107.7, 113.8, 91.3, 55.0, 49.9, 136.3, 109.5, and 108.6.
Roger, copy. That's good. Read down, and I'm going to turn you over to Bernie for the next one, Guy.
Discovery Houston, I have
Roger,
some...
copy, Roscoe, and you have a stuck mic.
Discovery Houston, I have some notes for you for your payload timeline when you're ready.
Go ahead, Marcia.
Okay, for the strap down at 1444, sun sensor ops are not required. And a couple changes.
Go ahead for payload timeline, Marcia.
Okay, Discovery dropped Discovery, we've been dropping comm here. Now that I have you, to avoid a V-bar violation at 1506, we'd like to schedule instrument safing after the strap down. Then we'd like to move the SPAS maneuver Earth limb scan up 5 minutes to 1515. Then a cryo cover open when the SPAS is in the Earth limb scan attitude.
Okay, Marcia, at 1506 you want instrument safing. At 1515 you want me to initiate the maneuver to the Earth limb scan. And when I get to attitude, I can go ahead and open the cover.
Good readback, thanks. We're about 4 minutes from an LOS. If I don't call you back, we're back at 1450.
Okay, see you then.
Discovery, one more note for you. We didn't see the gimbal check. We'll get it post the NC SK4 burn.
Okay, sorry, Marshall, we'll get it then.
Discovery Houston, just a note on my last note, we'd like strap down completed by 1506. I'm sorry, instrument safing completed by 1506.
Okay, Marcia, I understand.
This is Mission Control Houston. Discovery is just now passing over the Caspian and Aral Seas in the southwestern Soviet Union. That's a site that was sent up to the spacecraft, to the crew today by Earth observation scientists here at the Johnson Space Center as an interesting area of Earth to photograph. One of the interesting things about that area is the decline in lake levels. The last time that shuttle astronauts had a chance to photograph this area, and the last photographs that those Earth observation scientists have is from STS-61F, a shuttle mission that was in the August of 1985. Over the past 6 years, the levels in those lakes have declined extensively, as they have been doing for quite a while. That's due to the use of water from rivers that flow into those seas as irrigation in the drought-stricken area. It's a very dry area. Also, on this meteorological map, the white lines outlining the seas shows what their lake levels, what their levels used to be like. Now, the receding waters can be seen by the dark areas on this map. Also, on the Aral Sea on the right-hand side, there's an island present now on the left-hand side of the sea in this scene that was not there in 1985 and is a result of the receding level. A second site the crew is hoped to get a look at during the night is the Himalayas and the front range of the Himalayas. That's the area where the snowpack in this meteorological photograph melts. That's right at the edge of the mountains. It runs across this picture diagonally from the mid-right-hand side up to the top and top left. The interest is in the area of Nepal over here on the right-hand side of the screen in the middle. There's much deforestation in that area. It's been well documented by manned spaceflight photography since 1965, the range here and the area of deforestation on that front. One of the interesting aspects of that is that on shuttle mission STS-30, which was launched in May of 1989, vast smoke was photographed over this region, covering much of the area, which was apparently caused by burning the wood and deforestation in that area as fuel due to a political problem wherein India had cut off the supply of oil to Nepal. And scientists here on the ground are interested in seeing what the deforestation effects are at recent times. We've now lost communications with Discovery as it passes out of range of the Eastern Tracking Satellite. We expect to regain communications with the spacecraft in just a couple of minutes. All systems are working well on board with no problems. At 3 days, 14 hours, 48 minutes into the flight of Discovery on shuttle mission STS-39, this is Mission Control, Houston.
Discovery Houston, we're back.
Loud and clear.
And Discovery Teeter State Vector.
Discovery for payloads.
Stand by. Teeter State Vector coming to you, and we'd like an N2 repress on the spas. And go ahead for payloads.
Okay, Marcia, we were not able to acquire the star in time to get the strap down. If you could give us an alternate attitude for another star, we'll have to try that.
Okay, stand by.
And Houston Discovery for payloads, maybe a little bit of elaboration on that strap down is worthwhile. You give us an LOS time that apparently doesn't factor in the effects of the Earth's daylight albedo. When we get close to the Earth's limb in daylight, we lose the star pretty early, several minutes before you predict that the star is going to set. And between that and the time that we initiated the maneuver and when we got to the maneuver attitude, we just didn't have enough time to get the strap down complete.
Okay, thanks.
7 for the payload.
Go ahead.
First, since I've got the instrument saved, wonder if I could initiate the maneuver for the Earth limb scan earlier than 15:15.
Stand by. Discovery Houston, no strap down will be required. You have a go to maneuver to the Earth limb scan attitude, and I have a couple changes to the checklist, page 2-61 to start when you're ready.
Okay, I copied that, and I'm ready to copy your changes.
Okay, on page 2-61, the very last line, we will change the 5:40 call out for AIS template complete to 10:18.
That's 10:22.
10:18.
18, okay.
Next change on page 2-50.
Go ahead.
You can delete the call out at 0:10.
Okay, delete the AIS trigger at 10 seconds on page 2-50, okay?
Good readback. Third one is page 1-27.
Go ahead.
Delete step 2 AIS gimbaling. And that's complete.
Okay, I understand that one.
That's all for now.
And we copy, Marcia. Do you have some targets for us?
Working on it.
Okay.
In Discovery Houston, we're going to delay the NCSK4 burn for 1 rev to get a better feel for how the NCSK3 burn did.
Okay, we'll copy, we'll delay NCSK4 for 1 rev.
This is Mission Control Houston. That last communication with Discovery relayed the message to delay a burn we were about 3 minutes away from ignition of. That engine firing would have been a second station keeping firing. It was designed to pinpoint Discovery's arrival at a distance of exactly 10 kilometers behind the shuttle Pallet satellite, or a little over 6 miles. At the time that we perform a transition to near field engine firing, which is scheduled for after 1 a.m. Tonight. The decision was to delay this burn and watch Discovery's motions over the next orbit, and from that point on predict for the station keeping burn that was just delayed what the best method is for that burn in order to pinpoint being at that 10-kilometer distance, or the little over 6 miles distance at the time for the transition to near field. At present, Discovery is a little over 7 miles behind the shuttle Pallet satellite and moving closer to that satellite about 1 foot per second.
Discovery Houston, we're happy with our radar data, so we can dump some ops recorders. We'd like you to do step 3 in the KU ops Q card, page 8-6.
KU Ops step 3 coming up.
And Discovery Houston, we need you to load 2 Bravo for the AIS template for nighttime.
Okay, Marcia, as you probably saw, it was not clear to me whether we were going to get this thing off before dark or not. I will load 2B.
Okay, thanks.
This is Mission Control Houston. We're now receiving live television from Discovery as Discovery passes over the mid-Pacific Ocean on orbit 59. Actually, this picture is from the television cameras mounted on the shuttle Pallet satellite, which is following the same orbit of Discovery over the Pacific, only approximately 7 miles ahead of Discovery.
Discovery Houston, question for you. Which VTR are we on?
We're using VTR2. Which one would you like?
Stand by. Discovery Houston, one more note for the Earth limb scan, page 2-60. We need you to modify the roll to minus 86.65.
Okay, Marcia, that's good.
And I'm still working on your VTR.
And again, this...
Okay, we'll take VTR 1.
Okay, Marcia, VTR 1's on, 2 is off.
Thanks.
This is Mission Control Houston. This picture is still from the shuttle Pallet satellite, the low light level TV cameras, black and white cameras on that satellite as it advances across the Pacific Ocean 7 miles ahead of Discovery. Currently, the infrared background signature survey sensor, which is mounted on that satellite, is involved in an Earth limb scan, which is a scan of Earth's horizon to look at that area in the infrared and study the effects of the atmosphere in the infrared. The shuttle Pallet satellite and the pointing of it at the Earth's limb is being controlled remotely from Discovery, 7 miles back, by mission specialist Greg Harbaugh.
Discovery, one more thing for you on panel A6, TV to command.
Marcia, we have a KU switch in command. It's been there for a while.
No, the TV switch, please.
Okay, TV switch to command. Roger.
And
Go ahead.
Marcia, in looking at the flight plan, it was not obvious to me whether you wanted a day or a night data take there from the Earth limb scan, since you had day and then parentheses night. And I really think I could have gotten a whole day scan in and then the night scan. As it is, I'm having to wait until dark, I guess, to initiate it. I think maybe we missed one there.
Okay, well, sorry about that. We'll take a look at it, Greg.
we're now receiving live television from the cameras in Discovery's payload bay. This from a camera located in the forward right-hand corner of the bay. And Discovery continuing to trek across the South Pacific. About 4 minutes away from moving into sunset. This sunset Discovery's moving into should be the 60th sunset for the crew so far. In orbit, the crew sees a sunrise and a sunset every 45 minutes. Discovery is now nearing the Antarctic Circle as it moves toward the southern tip of South America.
Discovery Houston, we see good stars in the table, 85 and 63. We'll torque to those and cancel the alignment farther down the line. Discovery Houston.
Go ahead, Marcia. I understand we have stars in the table. Can you repeat that, please?
Yeah, I wasn't watching. We had a little comm dropout. Stars 85 and 63 look good. We'll torque to those and then cancel the maneuver later in the page here.
Okay, copy stars 85 and 63, and I'm go to torque to those.
That's affirmed.